Okay, today we're looking at the fundamental theorem of calculus, but before we get to the fundamental theorem of calculus, I want to work on this first problem up here. Okay, they have given me a figure, and this figure is made up of line segments and half of a circle. So that's what the figure is made up of. Okay, given that, we want to go through and find out all of these definite integrals down here on the bottom. Okay, so on A, we want the definite integral from 0 to 2 of f of x dx. Now, what does a definite integral represent again?
The area under the curve.
The area under the curve. So I'm interested in the area under the curve between 0 and 2. So how much of a circle is that between 0 and 2? It's a quarter of a circle. And what's the area of a circle? Pi r squared. And in this case, what's the radius? 2. So 2 squared is 4. So I end up with pi. Now, my answer is not pi, though. My answer is actually negative pi. Because I'm below the x-axis. Okay? So, if you're below the x-axis, your area is technically not negative. You're not going to have a negative area, but you always want to subtract whatever that area is. So, since I have pi below the x-axis, I'm going to subtract pi, and that's how we end up with the negative pi. Okay?
Triangle.
Move on to the next one. The integral from 2 to 6 of f of x dx.
One has 6 times 2.
What do we get there? I disagree with 6.
Why?
5.
I disagree with 5.
I'll disagree with everything.
Oh, because it's 1, 2, 3, 4, so it's 4.
4.
Oh,
Should be
It doesn't
4.
go from 0 to 6. It goes from 2 to 6.
dang.
Goes from 2 to 6. How far is it from 2 to 6?
4.
It is 4, and then how high is it?
2.
2. So 4 times 2 gives me 8. 8 divided by 2 gives me 4. Now, did anybody do it a different way? Because here's what I did. I went ahead and split that. And then I took this triangle over here and added it to that triangle, and now I have a rectangle that is 2 by 2, and that's how I got the 4. So there's some other ways to think about it.
Very difficult one to visualize.
I did it a lot quicker than you guys.
I don't care.
All right, next one. The integral from negative 4 to 2 of f of x dx. The integral from negative 4 to 2 of f of x dx. Look at that one. Tell me what you come up with. Anybody come up with something? Shouldn't take it that long. Take us that long.
Negative 4 pi.
Should be
Negative 1.
-1 minus 2 pi. I already know that the quarter of a circle is negative pi. So that means this quarter over here is also negative pi. So 2 of those is where I get that from. What are the dimensions of my triangle?
2 and 1.
2 and 1, and divided by 2 gives me the 1. And everything's below the x-axis, so that means I need to subtract everything, so -1 minus 2 pi. Yes?
Okay, so when you're trying to find the area under the curve, so you just find the area between the line and the x-axis?
Yes, it's always between the line and the x-axis. That's correct.
That makes more sense.
All right, go to part D. Part D is the integral from -4 to 6. This one should be pretty easy because
3 minus 2 pi.
you've already found everything you need. All right, what'd you say?
3 minus 2 pi.
3 minus 2 pi. How'd you come up with that?
You just
Yeah, because we said from from there to there was how much?
-1
Negative 1 minus 2 pi, and then we said from there to there was 4, and then we put those two together, that gives me 3 minus 2 pi. Okay, what about part E?
You just put out the values like 100.
What does the absolute value do to a function?
Make everything positive.
What do you mean by that?
So you have 3 plus 2. No. Basically V.
The answer is actually going to be 5 plus 2 pi. The absolute value takes a function and makes the function positive. So everything that is below the x-axis should now be above the x-axis. So that will be there, and this will be there.
Oh.
So now I'm looking at this area plus that area. So I know this area right here is 2 pi, I know this is 1, and I know this is 4. And when I add all that together, that gives me 5 plus 2 pi. Okay, so it takes everything and you're adding it instead of subtracting it. All right, then the last one. We have the integral from -4 to 6 of f of x plus 2 dx. You're going to have to remember something you did a couple days ago to be able to work this one.
Oh. I like that. That's fun though.
What you got, Jared?
23 minus 2 pi.
23 minus 2 pi
Yeah.
is correct. Now tell me the thought process on that.
Well, with the f of x, we already found it in D.
All right, so we want to separate these two, I believe is what you're
Yeah.
telling me.
So then you do is 10 times 2.
All right, so I already know this right here is 3 minus 2 pi. And this over here, the other day we learned how to integrate a constant. And how do we integrate a constant?
Subtract it now.
Yeah, figure out how far it is here, and that is 10. Multiply by that, which gives me 20. Add that together, we end up with 23 minus 2 pi. Everybody okay with that? All right, now let's get into the fundamental theorem of calculus. Fundamental theorem of calculus. I have a definite integral from a to b of f prime of x dx. The fundamental theorem of calculus says that f is equal to f of b minus f of a. Somebody tell me why that makes sense.
Because you have the b minus a thing that.
What's one thing a definite integral represents that we've talked about?
The area to the curve or the rate of change.
Not the rate of change.
What the function
It represents the change in the function above between your two limits. Okay? So, what is the function above f prime of x? F of x. And I want to know what's the change from a to b. So if I know what my function is and then I want to know what the change is between two x values, what do I do? I plug in those x values and do what? And subtract. And that's how we get it. Okay? Now, so that's the concept idea, is understanding that a definite integral represents the change in the function above it, which is what this is right here. That's the function above it, and that's the change from b to a. Okay? Here's how you will, here's how you'll work it out by hand. Okay? First thing we're going to do is we're going to find or integrate the function that's inside. So in this case, if I integrate f prime of x, what do I get? I get f of x. Okay, and then over here on the right, we're going to put our limits. We're going to draw a line. We're going to put our limits from a to b. Okay? And then all that's left is to do what? Plug in the top limit, which is b, and then subtract, plug in the bottom limit, which is a. So it's a two-step process. Step one is going to be integrate, and step 2 is going to be plug in my limits and subtract. That's the fundamental theorem of calculus. Okay? Alright, so let's do some examples. This will take us a little bit to get through. We're going to start with the second one. We're not going to go to that first example. We're going to go ahead and go to the second one. So I have the definite integral from -1 to 3 of x cubed plus 1 dx. So I want to evaluate this. If I'm going to evaluate this, what's the first thing I need to do? I need to integrate. So if I integrate x cubed, what do I get? X to the 4th over 4. If I integrate 1, what do I get? I get x. Then I'm going to put my limits over here. -1 to 3. So there's step 1, integrate. Good question. Courtney brings up, where's the plus c? I only need plus c if I'm dealing with what type of integral? Indefinite. If I'm dealing with a definite integral, I don't need it. If it's indefinite, that's where I need it. Alright, so step 1 was integrate, which is what I did. Step 2 is plug in my limits. Which one do I plug in first? The 3. So 3 to the 4th is 81. So that's 81 over 4 plus 3. So that's what I get when I plug in the 3. Then I need minus and plug in the -1. So if I plug in the -1, that gives me 1/4 minus 1. And now it's just a matter of cleaning it up. So I have 81/4 minus 1/4 gives me 80/4, and then 3 minus a -1 gives me plus 4. Okay, 80 divided by 4 is 20. So this definite integral evaluated gives me 24. Now that 24 represents 2 different things. Somebody raise your hand and tell me one of those 2 different things. Zach?
The area under the curve
Okay, the curve of what?
of f of x.
Not f of x. The area under the curve of that. Okay, and what does this represent? If you go back to the fundamental theorem of calculus, what was inside my integral?
F prime of x.
F prime of x. So it's the area under the curve of f prime of x between,
3 and -1.
I'd like to say -1 and 3. Okay, so that's one thing it represents. What's the other thing it represents? Somebody else.
Changing the function above it.
The change of the function above it between
Your interval, which is -1 and 3.
between -1 and 3. So those are the 2 things. I'm going to ask that every time after each one of these problems we do, because that needs to be nailed into your head. All right, so there's the first one. Next one. I have the definite integral from 0 to 1 of x squared plus the square root of x dx. The integral from 0 to 1 of x squared plus the square root of x dx. All right, what do I need to do first? Integrate. So x squared turns into what? X cubed over 3. I need to think of that square root of x as what? X to the 1/2. So that's going to turn into x to the 3/2, and what goes in front of it? 2/3, and we're going from 0 to 1. So step 1 is integrate. We integrated. What's step 2? Plug in. Which one do I plug in first? The top one. Plug in the top one first. So that gives me 1/3 plus 2/3. That's what I get when I plug in 1. Minus, I plug in 0. What happens when I plug in 0?
0.
I get 0. So that means my final answer is 1. 1 represents 2 things. Jasmine, what's one thing it represents?
The area of the curve of x squared plus radical x
Between?
between 0 and 1.
Very good. It's the area under the curve of x squared plus the square root of x between 0 and 1. Courtney, what's the other thing it represents? Between 0 and 1. Very good. Any questions on that one? All right, next one. I have the definite integral. Excuse me. Definite integral from 0 to pi of sine of x dx.
You okay?
Alright, I'm alright, I just gotta get this out. What do I do first?
Integrate.
Integrate. What do I get when I integrate sine?
Negative
Negative cosine. How do I know it needed to be negative?
Because
If
if
you
you
get
get
a
a code,
Because I ended up with the code. Very good. And it ended up with a code. So 0 to pi. Alright, then I need to plug in. Which one do I plug in first?
Top.
The top one. So that would be negative cosine of pi is what I get when I plug the top one in. When I plug the bottom one in, that's negative cosine of 0. So cosine of pi,
Negative.
negative 1, and then it becomes negative, so that makes it a positive 1. Okay? Over here on the right, what's cosine of 0? Regular 1, and then I've got a negative, which makes it negative 1, so I end up with 2. Okay, Melody, tell me one of two things 2 represents.
The area under the curve between 0 and pi
Of
of sine of x.
sine of x, very good. April, what else does it represent?
The change in oh my god, I can't write it. The change in cosine over the interval 0 to pi.
The change in negative cosine over the interval 0 to pi. Okay, or the way I like to say it is the change in the function above between 0 and pi. Okay, next one. All right, we have the definite integral from negative 2 to negative 1 of u minus 1 over u squared du. U minus 1 over u squared du. What do I need to do first? Integrate. What do I get when I integrate u? U squared over 2. Okay, before I integrate 1 over u squared, I want to think of it as what? U to the negative 2. So if it's u to the negative 2, what would its new exponent be?
Negative 1.
Negative 1 divided by negative 1. We're going from negative 2 to negative 1.
Are those is the smaller number always on the bottom?
It should be. It doesn't have to be. But it should be. Alright, clean this up before I plug in. So this is u squared over 2 plus 1 over u from negative 2 to negative 1. Alright, which one do I plug in first? Negative 1. If I plug in negative 1, that gives me 1/2 plus a negative 1. Then minus, plug in negative 2, that gives me a 2 minus a 1/2.
Teachers, please pardon the interruption. Just a reminder, auditions for the Titan pageant performances are during lunch today and tomorrow in room A114. Tuesday and Wednesday in room A114 during your lunchtime.
So I have 1/2 minus 1 minus 2 plus 1/2. So what does that end up giving me? Negative 2. Because I get the 1/2 and the 1/2, which gives me 1. The 1 and the negative 1 cancel, so that ends up with giving me negative 2. Okay? So Jairus, give me one of two things negative 2 represents.
The change in the function above it between negative 2 and negative 1.
All right, very good. Zach, what else does it represent?
The area under the curve of u minus 1 over u squared
Between?
between negative 2 and negative 1.
All right, so what does this tell me about that last statement that Zach said when we're talking about the area under the curve? Since it's a negative 2, what does that tell me about my function? What does it tell me about the area?
It's
Where is the majority of the area at? Under the curve. Why? Because it's negative. If I have a negative number, that means there's more area under the curve than there is above the curve. So that's something else we need to be able to notice. All right, next one. All right, I want to to integrate definite integral from -8 to -1 of x minus x squared over 2 times the cube root of x dx. Okay, what's something I want to do before I handle this one? All right, I don't like moving it to the top. I like dividing each thing by it. Okay, what do I want to do with that 2 though, instead of dividing both things by that 2? Move it all the way out, that's what I would do. So I would move that 1/2 all the way out and then separate. So we have x over x to the 1/3 minus x squared over x to the 1/3 dx. Everybody okay with that? Okay, reduce both of those. What is x over x to the 1/3?
X to the 2.
X to the 2/3. Okay, what is x squared over x to the 1/3?
X to 5 thirds.
X to the 5/3. All right. Now what do I want to do? Integrate. Leave this 1/2 out here. So what do I get when I integrate x to the 2/3?
3/5 x to the 5/3.
All right, 3/5 x to the 5/3. And what do I get when I integrate x to the 5/3? What's the new exponent? 8/3. So what has to be in front of it? 3/8. What's a quick, when you're dealing with fractions, what's a quick way to get your new exponent?
Reciprocal.
Add the
Add the denominator to the numerator, and that gives you your new exponent. So we did 3 plus 2, 5/3, 3 plus 5, 8/3. And we were doing this from -8 to -1. Ryan, what do I need to do next? Plug them in. Which one gets plugged in first? Top one does. So this would be 3/5 -1 to the 5/3 minus 3/8 -1 to the 8/3. Okay, so that's what I get when I plug the top one in, minus what I get when I plug the bottom in. So that would be 3/5 -8 to the 5/3 minus 3/8 -8 to the 8/3. And to save us class time, that right there simplifies to 57.113.
Is that before or after divided by 2?
That's after you divide by 2.
Okay.
Okay, and what does 57.113 represent, Chris?
The change in the function above it.
Change of the function above it between
-8 and -1.
-8 and -1. And Ryan, what else does it represent?
Which one did he say?
He said the change in the function above.
Change in function above the area under x minus x squared over 2 to the cube x, cube root x. Is that what it is? Between -1 and
Between -8 and -1.
-1.
Okay, and what do I know? What do I know about the graph? Since this is 57.113, what do I know about the graph of that thing?
It's mostly above.
There's more area above than there is below, if there's anything below. Very good. 2 to go. All right, we have the integral from -π/4 to 3π/4 of 3 cosecant cotangent dx. What happens to that 3?
It stays.
It stays. What do I get when I integrate cosecant cotangent? Negative cosecant. And we're going from -π/4 to 3π/4. Alright, what do I do next? Plug in. Now, this -3 right here, I'm going to move that -3 to the front. And then that way when I plug in, I only have to deal with the cosecant. So when I plug in, I'm going to have cosecant of 3 pi over 4 minus cosecant of negative pi over 4. Everybody okay with that move? So now we need to evaluate cosecant of 3 pi over 4 and cosecant of negative pi over 4. Okay, so I go over here to that. What's cosecant related to?
Sine.
Sine. So what is sine of pi over 4?
Uh,
1 over radical 2, so that means cosecant is
Radical 2.
radical 2. So that means both of these answers are radical 2. I just need to figure out whether or not they're positive or negative. Cosecant of 3 pi over 4, where is 3 pi over 4?
Second.
Second quadrant. Is sine positive or negative in the second quadrant? It is positive, so that means that's positive. Where is negative pi over 4?
Fourth quadrant.
The fourth quadrant. Is sine positive or negative in the fourth quadrant? It is negative, so that needs to be negative. So that means I'm looking at -3 square root of 2 plus the square root of 2. What is the square root of 2 plus the square root of 2?
2 radical 2.
2 radical 2, and then times the -3, that gives me
6 radical 2.
-6 radical 2 as my solution. LD, give me something that represents?
The change in the function above which be the -3 cosecant x between negative pi over 4 and 3 pi over 4.
Okay, April, what else does it represent?
The area under the curve from negative pi over 4 to 3 pi over 4.
Okay, and since it's negative, what does it tell me about that curve?
Areas below.
There's more area below than there is above. Okay, all right, last one. All right, we want to integrate from 1 to 4, 3 minus the absolute value of x minus 3 dx. Thoughts on this one? You should be wanting to do something to it.
Piecewise.
Piecewise. I want to change it to a piecewise. But before I change it to a piecewise, what can I do to this thing that might make things a little bit easier? What'd you say? Separate it. Very good. So I can do 1 to 4 of 3 dx minus the integral of 1 to 4 absolute value of x minus 3 dx. Everybody okay with that? And we should be able to quickly evaluate this first definite integral. What is that equal to?
9.
That is equal to 9. So I know that much is 9. Now I just need to figure out that other thing. And as Zach said, we need to turn it into a what? Piecewise. So we should be good at that by now. So somebody help me turn the absolute value of x minus 3 into a piecewise.
X minus 2.
I got x minus 3.
You got negative x plus 3.
I got negative x plus 3.
X greater than.
X minus 3 greater than or equal to 0. And x minus 3 less than 0. So if we clean both of those up, that means I have x minus 3 for x greater than or equal to 3, and I have negative x plus 3 for x less than 3. Now after I have it into a piecewise, how does that help me with my definite integral that I'm working on?
Do you integrate both?
I do need to integrate both. I need to take, you can't integrate an absolute value function. You have to separate it to be able to integrate an absolute value function. So somebody help me separate this thing.
So do you just find using the
I know I've got to start at 1. And I'm going to go from 1 to where?
3?
3. Why 3, Ryan?
Because it's where it changes.
That's where it changes from one function to the other. So which function am I going to use from 1 to 3?
The one that's less than 3.
The one that's less than 3. So that means negative x plus 3 needs to be in my first one. Then I need my second one, which is going to be from 3 to 4. And which function needs to be inside of that one? The top one, x minus 3. Why does that one need to be inside that?
Because it's greater than.
Because between 3 and 4 is bigger than 3, so that means I need x minus 3 dx inside of that. So take a moment and make sure you grasp what it is we just did right there. Okay, so I need to tell you, if I'm dealing with the integral of an absolute value function, I need to separate it into piecewise, and then I need to separate my integrals. And how do I determine what number will be shared between the integrals?
Where it changes.
Where it changes from one function to the next. So I went from 1 to 3, I chose negative x plus 3 because it was less than. Then I went from 3 to 4, I chose x minus 3 because it was greater than. Now, all that's left is to work out these simple ones. Okay? So I've got 9 minus, what do I get when I integrate negative x plus 3?
X squared over 2
Plus
3 plus
3x, and we're doing that one from 1 to 3. On the next one, integrate, that gives me x squared over 2 minus 3x, and we're doing that one from 3 to 4. So I've got my 9 minus, all right, on my first one, what needs to be plugged in first? 3. So if I plug in 3, that's negative 9 over 2 plus 9. That's what I get when I plug in 3. Then minus, plug in 1, so that's negative 1/2 plus 3. So that takes care of the first one. Then I move to the second one. Which one needs to be plugged in first over there? 4. So that gives me 4 squared is 16 divided by 2 is 8. And then minus 12. And I need to go minus and then plug in the second one. So I plug in 3. That gives me 9 over 2 minus 9. And to save us time, that thing ends up giving me 13 over 2 as my solution. Hey, Jairus, 13 over 2 represents 2 things. Give me one of them.
The area of 3 minus absolute value of x minus 3 between 1 and 4.
Okay, the area under the curve of 3 minus the absolute value of x minus 3 between 1 and 4. And what else does it represent, Zach?
The change of the function above it, or change of the function above between 1 and 4.
Very good. The change in the function above it between 1 and 4. So that's the fundamental theorem of calculus. Any questions? Okay, I'm going to go ahead and give you a worksheet, but I'm not going to make this worksheet due tomorrow. We'll spend time on it, working on it tomorrow. All right, nice job.
So